We are now going to continue with lesson 3.3 again. I should have written this here. Function notation. We're going to model a real situation, real life situation, using linear functions this time. So let me read with you this problem, this paragraph, and it says the graph here on the left shows the number of miles a helicopter is from its destination after X hours of its first flight. So I'm going to stop here. Actually, I stopped right here to analyze the graph on your left. The first flight, right here. Distance in miles corresponds to the y values or the output, and hours corresponds to the x-axis or the input. As you can see, at 0 hours, you are 300 miles away from your destination. As the time goes by, you are getting close to your destination. So it means that after 3 hours, you are now in destination. That's what it means. Now, on the other hand, and now I'm going to keep reading, on its second flight, the helicopter travels 50 miles farther. If they say 50 miles farther, I need to compare it to something else. It means that I'm comparing it to its first flight. If in its first flight it was 300 miles away from destination, well, in the second flight, now it is 300. Oh, let me do this in black. I'm sorry. So in its second flight, it should be like this. It should be 350 miles away from its destination. So at the beginning, I am right here. Now, it increases its speed by 25 miles per hour. Okay, so according to this, and you can see the function. The function represents, this equation represents the second flight. This 350 represents how far it is from its destination, 350, and that's where I start. But this time, its speed is 125 miles per hour, which means that every hour our helicopter travels 100 miles. I want to zoom in the graph and show you something important here. In the first flight, you can see this. At time 0, it is 300 miles away from destination. What happens after 1 hour? Where is it? At 200. So can you notice or can you see that in this case, 1 hour, after 1 hour, the helicopter travels 100 miles. Whereas in our second situation, they tell you that for every hour, it travels 125 miles. And we are assuming that this rate of change is constant. So the way it goes is like this. When it's 0, let me do 1, 2, 3, x. This is f of x, remember? So let's see what happens. Which flight takes less time? We need to figure out a graph for our second situation. It means how long is it going to take this second flight to reach x equals 0? What time? Is it going to, let me show you some possibilities, and then I'm going to erase them. Is it going to be something like this, or like this, or like this? I don't know, but we can figure it out with the information we have already. Okay, so let's see what happens. You might see that after 1 hour, all right. Oh, sorry, I deleted this. After 1 hour, you traveled 125 miles. So it means that after 1 hour, let me do, for example, here 300 250, 200, this is going to be 100, and well, and so on. Yeah, sorry, it's the intervals are not the best, so I'm sorry. I need to apologize for that, but this is going to be like this. If at time 0, and actually let me do this, not x, but actually, well, yeah, x, and then distance f of x. When the time is 0, it is 350 miles away from its destination. 1 hour after that, and remember that we are reducing by 125 each time, this is going to be 235. 2 more hours, and this is going to be 110. 3 hours, this should be negative 15. So can you see how I have 4 different coordinate pairs? Well, let's plot those over here. When it's 1 is 235, somewhere over here. This is going to be a little bit inaccurate, but you understand. 2 hours, this is going to be like 100 and something, and 3 hours is going to be negative somewhere over here. So let's take a look at that straight line. It's going to be something like that, and I'm sorry for this inaccuracy, but because it should be somewhere over here and so on. You get my point. Visually, how long would it take for it to reach 0 miles from destination? It's like 2 point something, right? I don't know, 2.8 maybe. Well, we can solve this using function notation, because look at that. I need to know this. When the output, it means f of x is 0. What is the input? Or meaning what is x? We already have the equation right here. Okay? I'm going to write it down here. F of x equals 350 minus 125x. We know that the output is 0. So I'm going to plug it in here. You will see what I'm going to do. 0 equals 350 minus 125x. What now? Well, again, solve for x. What should we do? Well, this is a trick. 125x, 125x. You know why I do this? Because I want to see a positive x. When you do this operation, you get 125x equals, these two cancel out, and then you got a 350. You see? You see where I'm coming from? So now look at that. We just need to divide on both sides by 125. All right, so 350 divided by 125. Well, of course, the left side cancels out, and then you get x equals 2.8. Oh, I was right. I'm sorry. Well, anyway. So it will take it 2.8 hours to reach its destination. So which flight takes less time? The second flight takes less time. That's it.